Hey guys, today we're going to start Unit 13, which is one of the most confused things that people talk about, and that's acids and bases. We got to iron this out and make sure you guys know what you're talking about, all right? So an acid is something that's going to donate H plus to solution. That's what an acid is. It makes H plus ions. So whenever you hear somebody talking about something acidic, that just means it has a bunch of H plus ions. That's it. Now, they can be very reactive and all that sort of stuff. Now, this is a very generic way to write an acid, HX, because you have a hydrogen and then some sort of other, either atom or polyatomic ion or something like that, and that's going to go into solution as well. Acids have a pH that is lower than 7. Lower than 7, that means it's acidic. Now, bases, on the other hand, I wrote M here. M is a metal. It could be any metal. Doesn't matter. All right? But you got to remember where metals are on the periodic table. They're metal hydroxides. Okay, so when these dissolve in water, you get the metal ion in water, and you get the OH minus ion. A base adds OH minus ions to solution. All right, now this metal usually is a group 1 metal. Sodium, lithium, potassium, rubidium, and that's pretty much it. All right, but they can be other ones as well, but this is what a base is, and the pH for a base is above 7. So this is what an acid is, this is what a base is. And I wrote the acids in red, well, it's supposed to be red, and the base is in blue because if you ever get litmus paper, which tests if something's acidic or basic, it'll turn blue in a basic solution, and it'll turn red in an acidic solution. So, kind of nice here. All right, what's the pH scale? All right, now, you're going to have to do a little math, but it's actually not that hard. All right, as long as we understand that like 10 to the negative 3.5 is a real number. You punch that in a calculator, you'll get an actual value. So here, pH is the negative log of H+. That's what it is, all right? Anytime you see a little p there, that means the negative log. That's logarithm function, or log base 10, all right, of the concentration of H+. And there's this whole thing that we could go into if we were going to do equilibrium, about how water auto-ionizes, all right? Now, there's one thing out there that has a pH of 7 that is neutral, and that's water. That's it. It's the only thing, all right? And it's neutral because when water breaks apart, you get the same number of H plus and OH minus ions. That's what makes it neutral. You have H plus, OH minus, you have the same amount, it's neutral, all right? But when it does that, all right, the concentration of H plus ions is always 10 to the negative 7th molar, which means if we punch 10 to the negative 7th into our pH equation, we're going to get a pH of 7. That is why water is 7. That's why we talk about 7 is neutral, okay? It's not a made-up number. It's not something that we just decided to do. It's actually a physical constant. This is what water does, so our pH scale is based completely on water. Water has a pH of 7 because its concentration of H plus ions is 10 to the negative 7th. But, like I said earlier, when water auto-ionizes, H plus and OH minus have the same amount. And so here, this is also 10 to the negative 7. So those are the same values. Again, that's what makes something neutral, all right? An easy way to think about this is here. If your concentration of H plus ions is 10 to the x, whatever x is, and it's going to be a negative value. It's going to be negative 1, negative 2, negative 3, blah, blah, blah. Then your pH value is just what x is. So if you have a concentration of H plus that's 10 to the negative 4th, your pH is 4. If you have a concentration of H plus that's 10 to the negative 7th, your pH is 7. If you have a concentration of H plus that's 10 to the negative 10.5, your pH is 10.5. And that's it. So this is how we go about doing pH stuff. You're going to have to do a few things here, but whenever I write the concentration of H plus, I am just going to write it as 10 to the negative, in this case, I'll do 2.5. But it doesn't matter. It's always going to be this way, which means finding pH is going to be really easy. You can also find the concentration of OH minus from this equation right here. And if you look at the notes that I've put up, I have boxed that in and tried to draw your attention to it. This is going to be an important one right here, all right? So if you have the concentration of OH minus, you can then find the concentration of H plus, and if you have the concentration of H plus, you can find the pH, all right? This is the last topic. I'll do another video on Thursday and Friday, and then next week you have a test for our last day of school, which is weird that it's in the middle of May.